I want to go over how to do a null hypothesis test with proportion. So a couple of things. First of all, you want to start with what you want to do. So in this case, I want to show that there are more days that are at or below freezing than not. So I look at my data, which I've sorted my data. I went through and I highlighted all my data, and I sorted it up here, custom sort. I sorted the second column, the one with the temperatures, from smallest to largest to make this easier. So freezing is 32 degrees. So I want to include 32. I said at or below freezing. So I can look down here and see there are 33 days that are at or below freezing. And if I highlight all my data, you can see down here I had 57 total. So n equals, actually I'm going to do this, x n 33, 57. That means my p hat is G6 divided by G7. Okay, so like 58% of the days. Now I want to prove that this is more, so more than half. So I'm going to say my null is that it's half and half. P equals 0.5. And my null I want to prove is P is greater than 0.5. Okay? So now I'm going to figure out, so I'm going to look at my formula. So here's my formula. So here, in here, my p hat is this 58 I just got. Come here. This is what I'm testing. So 0.5. These two down here are 0.5 and 0.5 because there's no hat in them. And this down here is my total n, so 57. So I'm going to actually do this all in Excel. So my top is going to be G8 minus 0.5. And a lot of times what I do actually is I write in the null right here, and then you can even use the formula for that, G9. This way, if you want to change stuff and play with stuff, you can do that. And then my bottom is going to be G9 times 1 minus G9. So that's my thing. And then I'm going to divide by G7. Okay. So let's see here. That was that. There's my top. Okay. I don't think I needed these two outer ones. Okay. So then my Z statistic, well, actually, let me come back here. I know why I was going to do it. Square root. I have to square root this. Square root this. Because if I look at the formula, that bottom is square rooted. So then my Z is G11 divided by G12. So 1.19. I need to look up my critical value. So my Z, my CV to compare to, I'm going to look up, and I'm going to actually use this because I want it all in here. So I'm going to do down to normal distribution inverse, and I'm going to do it 0.05, and I've only got one tail, so I don't want to do that. I want to do, come here, normal. Let me come back up to normal. I want normal S inverse. Okay, 0.05. You could do anything, but I'm just doing 95%. I'm one-tailed, so I've got it all. I don't have to divide it in half. So 1.67, and of course, since I'm testing more, then I would use the positive. So I would use the positive 1.67. My value is not larger than this, so I would have to fail to reject, okay? Because if I drew my thing, I'm looking for that I'm past it, I'm bigger, I want this value right here, okay? This is my value. I need this value bigger than this value, the positive version of this value. It is not bigger than that. So therefore, I have to fail to reject, and I'm not able to conclude that there are more days at or below freezing than not. And so I'm really not able to conclude anything from this test at 95% significance. I might be able to if, like, for instance, I do a 90%. No, I would still fail. But you can come through and you can check. And obviously, you know, if I do 40%, you can see, oh, that's easy to prove. The farther you are away, the easier it is to prove something. So hopefully this helps you set up this type of problem.